right, the second case of exceptions to the octet rule are when we have octet-deficient molecules. So basically, this means we're going to have a molecule that's stable even though it doesn't have a complete octet. And these tend to happen in group 13 molecules and actually happen almost exclusively in group 13 molecules, specifically with boron and aluminum. So anytime you see a Lewis structure with boron or aluminum, you want to just remember that I should look out to make sure that these might have an incomplete octet. So look out for that when you see those atoms. So let's look at BF3 as our example here. And what we see for BF3 is the number of valence electrons that we have are 24, because the valence number of electrons for boron is 3, and then 3 times 7 for each fluorine. For total filled octets, we need 32. So that means we need 8 bonding electrons. So let's assign 2 to each bond here. And then we're going to have 2 extra bonding electrons. So let's just arbitrarily pick a fluorine to give a double bond to. And then we can fill in the lone pair electrons. We have 16 left over. So thinking about what the formal charge is, if we want to figure out the formal charge for the boron here, what we're talking about is the valence number for boron, which is 3, minus 0 because there are no lone pairs, minus 1/2 of 8 because there are 8 shared electrons. We get a formal charge of minus 1. What is our formal charge, since we learned this on Monday, for thinking about the double bonded fluorine in boron? So look at your notes and look at the fluorine that has a double bond with it. And I want you to go ahead and tell me what that formal charge should be. All right, let's take 10 more seconds on that. Okay, so 49% or 49%. So let's go look back at the notes. We'll talk about why about 50% of you are right and 50% need to review, which I totally understand you haven't had time to do yet, your formal charge rules from Monday's class. There were other things going on. But let's talk about how we figure out formal charge. Formal charge is just the number of valence electrons you have. So fluorine has 7. You should be able to look at a periodic table and see that fluorine has 7. What we subtract from that is the number of lone pair electrons. And there are 4 lone pair electrons on this double bonded fluorine. So it's minus 4. Then we subtract half of the shared electrons. Well, we have a double bond with boron here, so we have a total of 4 shared electrons. And when we do this subtraction here, what we end up with is a formal charge of +1 on the double bonded fluorine. Without even doing a calculation, what do you think that the formal charge should be on the single bonded fluorines? Good, okay, it should be 0, and it is 0. The reason it's 0 in terms of calculating it is 7 minus 6 lone pair electrons minus 1/2 of 2 shared electrons is 0. The reason that you all told me, I think, and I hope, is that you know that the formal charge on individual atoms has to equal the total charge on the molecule. So if we already have a -1 and a +1, and we know we have no charge in the molecule, and we only have one type of atom left to talk about, that formal charge had better be 0. Okay, so this looks pretty good in terms of a Lewis structure. We figured out our formal charges. These also look pretty good, too. We don't have too much charge separation. But what actually it turns out is that if you experimentally look at what type of bonds you have, it turns out that all 3 of the BF bonds are equal in length, and they all have a length that would correspond to a single bond. So experimentally, we know we have to throw out this Lewis structure here. We have some more information. Let's think about how this could happen. So this could happen, for example, is if we take this 2 of the electrons that are in the BF double bond and we put it right onto the fluorine here. So now we have all single bonds. And let's think about what the formal charge situation would be in this case here. what happens here is now we would have a formal charge of 0 on the boron. We'd have a formal charge of 0 on all of the fluorine molecules as well. So it turns out that actually looking at formal charge, even though the first case didn't look too bad, this case actually looks a lot better. We have absolutely no formal charge separation whatsoever. It turns out, again, boron and aluminum, those are the two that you want to look out for. They can be perfectly happy without a full octet. They're perfectly happy with 6 instead of 8 in terms of electrons in their valence shells. So that is our exception number 2.